Hey, everybody. So that picture, by the way, the events team has absolutely hated that I haven't updated my headshot. So they finally wrangled me and got me to take a new headshot. So that will probably be the last time you see that at any of these summits. But just know that I went kicking and screaming. Anyways, Canoto. So this is something that I actually started working on when I was on vacation, and it's something that I have felt passionate about over the past now 7 years working on Avalanche Go. And I finally basically said, all right, I just need to do this the right way. I can't keep working on this. So I'm going to start at the beginning, a very, very high level of serialization formats. Might be overly detailed for a lot of you, but we'll kind of start from the beginning and run through. So first question, what is a serialization format? Many of you may know, but it's just a way of representing kind of something meaningful, like a block or a transaction in a format that is kind of agreed upon beforehand, something we can store on disk, something we can send over the network. So it can be encoded in many different ways depending on the format. So as an example, we switch from kind of our abstract account, Alice amount thing to, say, JSON is a serialization format. So this is a great example of a random thing that I found at 2 a.m. last night as just a C-chain transaction. RLP encoded as hex. You have basically no idea what it is. In JSON, that's what it is. So you can see different encoding formats. They have different usages. JSON is very nice because it's human readable. RLP is a little bit nicer for, say, for machines rather than humans. RLP sucks as a whole as well, but it's nicer than JSON probably. So why should anyone care about serialization? The quick answer is maybe you shouldn't. So when we were first working on Avalanche Go, I was explicitly told by Goon, stop working on this. This is taking too much of your time. Just pick a serialization format. But after 7 years of dealing with that terrible decision, I think that we kind of have rationale for caring. So if we look through some horrific code, we can see some fuzzy parsing that's come in over the years. We can see some very interesting block formats that come out of our serialization. We can see some interesting vertices with different serialization versions that we kind of have to manually maintain. And to say that this has been a nightmare to maintain and ensure correctness of is almost an understatement. So stepping back a little bit, let's talk about some of the kind of properties of serialization formats and why our existing format kind of sucks. So some very basic serialization format kind of properties is speed and size, right? So you want to make sure it's very compact so you can send stuff over the network efficiently, you can store it on disk efficiently, and you want it to be very fast so you can quickly serialize and deserialize things. So these make sense. Backwards compatibility is essentially saying, hey, if I introduce something new, will my new code still understand the old format? So this is something that the existing Avalanche Go codec does not do that really sucks. So I would definitely recommend having this support. Forwards compatibility is a little bit more interesting. Will your old code support the new format? In blockchain, we essentially never want this because if someone issues a transaction with stuff that you don't understand what it does, you probably shouldn't process it. Everything needs to be canonical. So forwards compatibility is actually a feature that you explicitly do not want in blockchains, but it's a feature that a lot of serialization has, or many serialization formats tout as a feature. We have human readability, self-describing, so JSON is very nice because you can just kind of look at it. The removal of old fields, this is a little bit more specific than backwards compatibility. It's allowing some additional features there. Cross-language support, making it so that, hey, this has already been implemented in, say, JavaScript, Java, Golang, Rust, just kind of out of the box. And then these last things are very blockchain specific, which is canonical, and then this canonical specification thing. So we're going to get back on the canonical specification thing towards the end of the presentation, but canonical essentially just means that you only have one possible representation of that thing. So if you hash it, if you sign it, that's guaranteed to be the same representation. Some existing serialization formats, very the list goes on. You have JSON, Avalanche codec, RLP, SSE, Protobuf. We have ASN1, Borscht. The number of these that are actually used by Avalanche Go is almost all of them. We don't use Borscht, but I think the Firewood effort had originally pushed for that at one point. But yeah, we use kind of a mix of all of these. So what do those formats support? I put this loading thing here because this next slide is going to be completely unreadable. Again, 2 a.m. All right. We don't need to actually care about this. All you need to see is there's a lot of red, there's some green, and there's a couple like yellow warning signs. Also, again, 2 a.m., also written by ChatGPT, may not be completely right. I QA'd it a bit, and I think it's fairly accurate. But some of these things we don't really care about in blockchain. So we're going to remove a couple. Human readability is essentially a non-starter from a performance perspective, so we're just going to take that out as a feature we don't care about. Similarly, forwards compatibility and self-describing are almost completely at odds with being canonical. So we, again, take that out. If we look through here, one thing that's interesting is the canonical specification. Essentially, none of them have this. The Avalanche codec kind of did. I think with Ilya, he did a pass on trying to introduce this for HyperSDK, but really none of them have this kind of canonical specification. But Protobuf is pretty nice. The only real issue is the lack of canonical formats. So my opinion on this has kind of always been, wouldn't it just be great if you could have Protobuf that was canonical? So this is, again, the kind of namesake of my project, my little hackathon that I did when I was on the beach. So canonical proto is Canoto. So what is Canoto? It's essentially just proto, but rather than being forwards compatible, it enforces a canonical subset. So if something is valid Canoto, it is valid proto. However, if it is valid proto, that does not necessarily mean it's valid Canoto. This means that Canoto inherits a lot of properties of proto while just replacing the forwards compatibility. So whenever we generate a Canoto message, we can actually generate a proto file that then just inherits all of the existing tooling that proto has. So if we introduce, say, a new transaction type or a new block into Avalanche, we don't actually have to immediately then go and update, say, the JavaScript library for parsing this to show on the Explorer, because we just have it natively done in the proto file. So the proto will just immediately update. Then the JavaScript stuff can immediately generate the new format. So if we look, I almost just fell over. If we look over here, the properties of Canoto still have some red X's, so we're going to remove them. This is the subset of things that we said that we cared about earlier. So the nice thing here is this gives kind of exactly what I think is useful for a serialization format for blockchains. So I'm just going to dive right into a very simple example. This is not a really good transaction because the from is just an address rather than a signature, but you can kind of get the idea. It's essentially you just specify your Golang struct and you have everything that will get auto-generated from there. So we have the from, the to, the amount, state keys, and we have all these different kind of formats, and it automatically generates everything that you need. The Canoto data is something that internally is used by the serialization library to avoid any memory allocations during the serialization. So this is essentially a performance thing that we focus on. So Canoto, even though it's a little bit more restrictive than Proto, it's more efficient than Proto in all of the benchmarks that I've run. So the auto-generated code produces something along these lines. There's more things that get generated to support efficient serialization and deserialization, but these are the ones that like people actually care about. So you can marshal Canoto, you can unmarshal Canoto, and then you have this very interesting Canoto spec. And the Canoto spec is something that might not be immediately obvious on why people would care about it, but it's really kind of the killer feature for Canoto. Again, shout out to Ilya with his work on, I think, MetaMask snaps on this. So Marshall Canoto, just a note on performance, is guaranteed to only perform one memory allocation, and unmarshal Canoto can do the minimum number of memory allocations required for actually allocating your type. So if your type is fixed size, then unmarshal Canoto wouldn't perform any memory allocations. As a total aside, didn't really talk about this, interfaces in Golang are horrific for memory allocations. So anyone that says, oh, hey, you should take in like an IO reader or IO writer to allow like buffered reads and writes, that can be important if you're serializing something extremely large, but in practice, it almost certainly significantly decreases the performance of reading and writing. So we don't do that. But yeah, so here's the example kind of auto-generated proto that spits out. So we have this valid proto thing, and then this proto file can be used to auto-generate any external reader for your Explorer, whether it's written in, there's some weird, whatever, doesn't matter. Written in Java, it'll work. But the killer feature of Canoto is universal parsing. So this is something this is the big reason why we have kind of pushed for integrating Canoto into the Hyper SDK, and I would definitely recommend utilizing this in any custom VMs built by the Hyper SDK. So a background here is that hardware wallets suck. And hardware wallets, while being essentially the best-in-class security for normal users of issuing transactions in blockchain interaction, aren't that good at actually telling you what's happening. The hardware wallet needs to be able to parse these transactions fully and say, hey, I'm performing this call, I'm doing this operation. But in something like the EVM, you know which destination transaction you're calling. The payload is some kind of amorphous hex string. You don't really know what's going on there. If you can read hex string, you're more powerful of a developer than I am. I'm not great at reading hex strings, at least since debugging the P2P network 6 years ago, which that was depressing, but I actually did get pretty good at reading hex strings for that. Skill that I've lost. Anyways, we can read through here. There's been many vulns, many hacks. The most recent one was, I think the biggest blockchain hack in maybe ever earlier this year, and it was basically around people signing transactions on their ledgers and not actually like verifying that they were the correct transactions. That was a more complex hack as well, but it involved that component. So the interesting component about universal parsing is we want to basically have some like abstract payload, but we don't know the format of it because it's generic across any, say, contract that you're calling. What we want to include additionally is a payload commitment for the kind of specification of the payload. And what this would be used for is this would be used for whenever you call a contract, in addition to parsing the payload, it will verify that the payload commitment matches its expected commitment. So the reason that this is important comes out when we actually go to display the transaction to the user on the ledger side. When the ledger is displaying the transaction, it can enforce that it is only signing a specification that is committed to in the transaction. And that guarantees that this transaction is only valid if this is the true specification for the function I'm calling. This essentially guarantees now that the ledger has the ability to fully display to the user all of the actual true semantic values. So rather than some hex string, it can say, I'm sending all of your money to North Korea, and then you could say, no, decline. Or maybe say, like okay, depending on if you're Kim Jong-un or not. I don't know. But yeah, so this universal parsing kind of trick essentially allows the ledgers to have a single universal implementation to display any arbitrary payload without needing to have a custom ledger app for any specific, say, EVM payload. So you can see here that the specification bytes are arbitrary. Yeah, so I think that this is the high kind of level description of Canoto. I didn't get into any like specific byte manipulation stuff. There's a lot of fun optimizations that we did around compiler, like tweaks, things like that. But yeah, I think, are there any questions about Canoto, the use cases, stuff like that? Feel free to star the GitHub repo. That's how that's like likes for my, Twitter. I don't post on Twitter, but I do respect GitHub stars. Yeah, any questions?
Question, guys? Seems all good. Thank you so much, Stephen.